So what we're going to do now that we've done this, the main reason that we did this is we can now start doing our layer by layer solution. And this primes it for that purpose. So I'm going to start off with a white layer, and I'm going to start filling these corner pieces in now. And that's done, you know, nothing fancy. So here's the green and orange, so that's going to come over here. So I just start filling in by the usual methods. Put this in here. Now you might notice something as I'm doing this. As I'm trying to put this in and putting in my first layer, you may notice that I'm messing up what I just did. Why would I do that? Have I gone completely bonkers? Am I insane? Did I just do all that work for nothing? Well, we have our first layer here, but look what we did. We apparently messed up everything that we put in, but in actuality we didn't, because notice all of these sides have their edges, both edges are kind of in place one way or the other, which allows us to put these edges down in place in the proper configuration of where they need to be. So we can apply an algorithm to just flip these down because these are now in place. So just to give you an example of what I mean, here's an example. We need to put a red one here, red and blue. So here's red and blue right here. So it's just a matter of putting this down here. The algorithm to do that is exactly the same algorithm that we did with our white Eden circle cube, if you remember that. And that's going to be, if it's on the left side, basically just kind of cycle it around. And that you do by, in this case, you're going to go L, I, U, L, U, L, I, U, L, then bring it on back to UI, LI, UI, L. And that brought that into configuration. So let's do it again over here. We need the orange and blue. Here it is over here. This is orange and blue. So we're going to just move that into configuration here, and now we're going to do the same thing but on the right side. So that's going to be R, UI, RI, UI, R, UI, RI. Then swing it on back with U, RI, I'm sorry, U, R, UI, U, RI. Sorry, once again, I can't chew gum and talk at the same time, or do this and explain it at the same time. Anyway, that put that into position. I'll have that written in the notes. Anyway, here's yellow and green. So we're going to put that into configuration. This is going to go down here. So it's that same algorithm. And it's as simple as that. Now notice it puts it right into configuration here. Here's the red and green. So I'm going to move that here to move this into place. And we have our second layer. So we have our first two layers here. And now it's just a matter of solving the top. This is exactly like we did with the Mercury cube. We already should have our cross pre-manufactured, so it's a matter of looking at these centers. And there's a variety of potential situations we can have. This is the simplest of situations where one is solved and the rest are not. So we just do that algorithm that we've talked about to cycle these guys around. And that's going to be the R, U, RI, U, R, 2U, RI. And we're not quite there yet, so do it again. And there you can see all these are in the right position. So that's one potential situation. Now I invite you to look at the Mercury Cube tutorial to deal with all other situations where we do adjacent middle or opposite middle swapping, dealing with the parity situations. There's absolutely no difference with that. So I would refer you to that because it's done exactly the same way. By way of demonstration, here's another middle situation, just to review again, I guess for the sake of posterity. This is solved, these two are not. So recall that what I want them to be is I want these to be within either 180 degrees of each other or solved. And these are both 90 degrees. So I'm going to do an adjacent middle swap to get them that way. It's going to produce parity here, and it's going to cause a rotation of these centers. But we've talked about how to deal with it. I'll just kind of demonstrate it again for here. The adjacent middle swap, as you can look in previous tutorials. And what this does is, aside from creating parity here, is it did put everything within 180 degrees of each other. So now I'm just going to do opposite edge swaps, which will drag all these over, but solve these sides and fix this parity. And predictably it solved these guys, but we have these to go. So because I don't want to do another swap like that, because I'll produce parity and get stuck into a parity trap, I'll just fix the parity here in the way that we talked about. The R to U, R to U, R to U, R to U, R, and everything is fine. So this is just another demonstration of what you already know. And then we just fill in the rest of our last layer over here. See if there's anything in the proper place. This is not. So we do our algorithm for that. Are we there yet? Yeah, so now it's just a matter of rotating these guys back in. And we reach the point where if this were a normal circle cube, it would be done. If this were a Mercury cube, well, like Mercury and Venus, we've now solved the outer shell, and it's a matter of putting these corners, these middle corners, back into place.